So hello everyone, welcome to this video. This video I'm going to explain to you how to use the interface of scrap mechanic quantum right here. So let's start with this portion right here. Oops, didn't mean to do that. So yeah, here I have a yellow switch, and when we activate the switch, this switch changes the source from which we're taking the instruction. So right now it's deactivated, as you can see. That means that we're taking instruction from the memory, from the switch memory. And here it is displaying which instruction we'll be performing. And if we activate the switch, now, when we activate the switch, we're taking the instruction from this part, right? So as you can see, these gates are now lit with different instruction. It's the same, doesn't matter. So let's actually execute the instruction. So to execute it, we press this button. Okay, so this instruction loaded the number 9 into the accumulator, and the accumulator is this part right here, these gates right here. So let's turn these off. So okay, great. Let's for example, let's store it into address 0. So 2 is the store, and as you can see, now we have these gates lit up. So this is the output from the memory, from the RAM, in which our number is stored. And this part right here also changes it. As you can see, in address 1 we don't have anything. So yeah, it affects the number in the memory anytime, not when the certain instruction is activated. And we have a 6-bit address for RAM. So be aware that you cannot save more than 64 numbers. Okay, great. Now let's load number 6 into the accumulator. As you can see, now we have a number in the memory and number in the accumulator. Let's perform a simple action. I think addition will be simple enough. So right now what we're doing is, as you can see, these blue gates are activated now. So, and this is these blue gates means the output from the ALU. And as you can see, they haven't changed. But we want to add a number in the memory to the number in the accumulator. And to do that, we activate this sign bit right here. And as you can see, now we have a different output from the ALU. As you can see. And when we actually execute the instruction, now the output from ALU is stored into the accumulator. So I think it's simple enough. Okay, great. Now let's store number 15 in binary again to the memory address 0. Let's perform some other instruction, well, probably a little bit harder one, which is multiplication. So not sure. So this is I think it is 22 in binary. Yeah, it's 22 in binary. Well, I was a little bit wrong. It was actually 20 in binary, not 22. And it is multiplication. So if we just want to multiply, for example, 15 to some number not in the memory, then we can just have this switch deactivated and multiply it. Right now we're multiplying it by 1, so it is 15. 15 multiplied by 1 is 15. Let's multiply it by 10. So as you can see, now I have 150 in the output. Let's execute it. And multiplication takes a little bit more time, so it is bigger delay. And as you can see, here's our 150. Now, let's subtract number 150. Let's subtract from 150 a number in the address 0. So subtraction is this instruction. It is 21. Yeah, I'm extremely good at binary. This is actually 19, not 21. Yeah, even though I created this computer, I still am not fluent at binary, if you can call it like that. I hope I'm not wrong. Yeah, so and let's subtract it. Let's subtract it. Yeah. Let's execute it. Here we have 145. Wait, no, 135 in the memory. So yeah, I think that's pretty much all for this. Like for this part right here. So this light yellow gates are the actual bus. So as you can see here, here's all the instructions that my computer have. And as you can see, here we have like a scheme. So what this means is we have a bus, and where these arrows means transferring the number. So we're transferring the number from the bus to the ACC. ACC is accumulator. These sticks mean OR, so we can perform either bus to accumulator transfer or memory to the accumulator. And yes, let's store this, for example, into 1 for now. And let's load. So right now, if we just load 0, then we will load 0 into the accumulator. But if we activate the sign bit, we're loading number from address 0, as you can see here. So yeah, when we have this OR, yes, when I have these sticks, those mean that on the left part we have sign bit deactivated, and on the right side we have our sign bit activated. Hopefully it's not that confusing. So std store data, and as you can see here, accumulator transferring memory. So we're transferring the number from the accumulator to the memory, or from the bus to the memory. From the bus to the memory? Not sure. Wait, is that even possible? Not sure if I wrote this correctly, because that's very weird. Oh, I guess I can. Wait, how is that possible? What? Bus to memory. I know that we can do... I think I've made this graph incorrectly, I'm not sure. Yeah, that's very weird. Accumulate it to memory, we can do that. We cannot do from bus to the memory, it's impossible. Weird, I think I've made this scheme wrong. Interesting. Well, okay, I think it's the only mistake right here. Yeah, I haven't noticed that I wrote this wrong. Okay. So, yeah, we're transferring the number from the accumulator to the memory. And only like that, we cannot actually store anything. Like, we cannot do that. actually haven't done this. So store So right now what are we doing is yeah, we're doing weird stuff. Huh. Okay, that was confusing. Okay. Jump F, jump function. So we're transferring the number from the bus, from this spot, to the PC. PC is program counter. So this thing right here. So I just noticed a small problem with my explanation. So I said that the bus is these green gates in the input, but the bus is actually those light yellow gates. I already said that. I'm not sure why am I referring to the program counter green gates as the bus, but actually those yellow gates that I showed earlier, and I said it, that those gates are the bus. And this symbol right here is end. Just so we're performing two things. I'm first we're a little bit incorrect. Let's let's continue. So let's, for example, call a function at address 9. And now, as you can see here, our program counter changed its value to the value that was here. And now, I don't have a stack display right here because we don't really need it. But right here, we have a stack counter. This is stack counter. This is the stack itself. Let's decrement it. And well, our address was 0, so it's stored the address 0. So yeah, that makes sense that it's empty. But yeah, it's incremented. And now, if we have next instruction here, return. And when we do return, we will load a number from the bus to the accumulator or from the memory to the accumulator. And we're grabbing the number from the stack and loading it back into program counter. So let's return 15 and look at the program counter. Actually, no, let's not load 15, let's load some random number. Amazing. So let's return this beautiful number. And as you can see, our program counter changed, and our accumulator number in the accumulator also changed, as you can see here. So these sticks mean OR, and this symbol right here means AND. Also, we have a jump instruction, which I recommend probably to not use because it's not useful. Because it's simply not great for example, if you want to add something. Yeah, I kinda just don't. I'm not using it because it's hard to. Always you have to specify which location in the memory, to which location in the memory we need to jump, and it's annoying. So I use skip instruction. This one and this one. So yeah, jump is bus to PC. So just jump. Everyone knows what jump is, right? Here we go. Let's jump back. And then there is conditional jumps. Jump P, which means jump if our accumulator is bigger than 0. Then there is jump Z. It will perform the jump instruction when the accumulator is equal to 0. And jump N means that our we will perform the jump instruction when our accumulator is negative, when it's less than 0, as you can see right here. Then there are skip instructions. Skip instruction, what they do is they will simply add to the current address some another number, right? So PC program counter plus bus, or PC plus memory. So yeah, we can specify the number in the memory. That's very useful, for example, for switch statements, you know? We can do switch things. So that's very nice. Skip p, skip z, skip n. The same thing with like jump p. So yeah, if our accumulator is bigger than 0 with skip p, then we will perform the skip instruction. I think it makes sense. Then there is arithmetics, which I already shown. It's the same for Boolean arithmetics. Also there is shift operation. Oh, probably I should say about shift operations that they're not that simple. Let's load number number 3, and let's shift it. So right now we're shifting it 0 times, but you know, some magic. So in most languages, I mean at most computers, we can do just shift some number 1 time. That's not great. I want, for example, to shift a number a bunch of times, right? I would have shifted number by the memory, but it's 15, so our number will just, yep, it just disappears. But okay, let's shift it 3 times. And where is the number? Is it the shift operation? Yes, it is. Something bad happened to my shift operation. What? Well, that was very unexpected, that my shift operation just broke. I really wasn't expecting this. Huh? It's not even lit right here. What? Did my shift operation broke? Oh, I'm doing the wrong shift. I'm doing the right shift. Yeah, that's the thing. Okay, that was pretty awkward, I guess. So yeah, we're left shifting. Oh, I mean right shifting, of course. If we shift it 3 times, it will go right here. Well, somewhere right here. Now let's do a left shift, so we will left shift. And yes, it works fine. Okay, our shift operation is working great. It was me that was stupid. So as you can see here, we shifted 3 times. We can do that 15 times and have a just negative 32,000, I think. Yeah, about something. Negative 2 to the power of 15, I think. So yeah, because we will overflow to the sign bit right here. So yeah, that's, I think, yeah, I still have to mention some things. So, okay, this part right here. So, as you saw here, we have type. And this is exactly right here. Is the same that, like, it shows which type of, what operation is executing right now. So, for example, load. It's a memory operation. Multiply is arithmetic. Let's go with not, because I know what this is. So not is Boolean operation. Then we have special operations, and they're all at the end right here. We'll perform UI. So, and it is this purple color, and also we have another instruction which is just halt, as you can see. So now let's execute the UI, which is user input. That was user output. Is that even possible? For some reason I messed up. So yeah, we have user output. It just outputs the number right here. So yeah, we can display some numbers right here if you want to. Let's perform the user input. So okay, And as you can see here, this gate lit up. So it means that we have to input some number or the computer will not continue with the instruction. And we can load anything here. And when we press the button, it will load the number into the accumulator. So yeah, this is the user input. This is user output. So I think that's all that I can say about this computer. This actually I have forgot about this. So these are the states on which our instruction is. Not sure how to explain this. So I have like these fetch, some decode. Yes, by this I meant the instruction cycle, and it consists of fetch, decode, execute. So yeah, that's very much all. Now I'm sure that I explained everything on this computer. Maybe except these buttons. Yeah, these buttons just increment and decrement. This green will increment fast. This will reset. Yeah, now it is that's all. I think I explained everything. So yeah, bye.